This video is about chromatography. Chromatography is the separation of two colors. In this case, you can see the color green, and the green mark is composed of two dyes, yellow and blue, and when mixed together they make green. But when you have an experiment and you put a piece of filter paper and you put a stripe of green on it and you put that in a little bit of water, the water will soak up, and this is what happens. The dye is going to travel along with the water. However, the two different dyes, yellow and blue, respond differently to the water, and they start separating. So we can see the yellow above the blue, and the longer it takes, the further apart they will be. So at the end of the experiments, the yellow is still higher than the blue. There are two things that are important here. First one is how well does the dye adsorb to the paper, adhere to the paper, and how is the solubility in the solvent. So if the adsorption to the paper is low and the solubility in the solvent is also quite low, you won't travel far. But when, like in the yellow, the adsorption to the paper is low but the solubility in the solvent is high, we will end up higher in the chromatogram, as you can see in the picture. We can also do some calculations with this. We call that the RF factor. You will find chromatography, an RF value, page 155, page 156 in your book. So I suggest that you read that as well. We start off on the baseline and we put our samples there, and then we put it into water or any solvent, and then the solvent soaks up in the water, and eventually at the end the solvent front will reach a certain point, and that's the distance from the baseline traveled by the solvent. But the dyes also travel. So the distance from baseline traveled by the solute, here indicated by A. And if you divide A by B, you get a value that is always between 0 and 1, and that is called the RF value. For every chemical, these are different. But if I have the same chemical and the same solvent, that one will be the same. For instance, if I have a yellow dye and I use that time and again, it will always end up with the same value. I have an example which I prepared some time ago. This is what I started off, this is what I got, and I measured the distance between the baseline shown at the bottom and the front, which my pencil indicates, and also I looked at a yellow dye and I indicated the front of my dye. If I measure the values, the solvent front has traveled 9 centimeters and the yellow dye has traveled 7.7 centimeters. So if you do the math, 7.7 centimeters divided by 9 centimeters, that will give you 0.86. So that is the RF value for this yellow dye. If I use that one again and I measure it again, I will come to the same value over and over again, even if my distances would not be the same. So it's the percentage. That is chromatography in a nutshell.